Hello everyone, you are learning physics from Uncle Irodov, and in this module we will be solving Irodov's 1.15. In this problem there is an elevator whose height is known, which starts from rest and ascends at a certain known acceleration. There is a bolt at the top and that bolt falls down, hits the floor of the elevator. And they are interested in knowing what is the bolt's free fall time. Now this can be solved from either the elevator frame or from the ground frame, but it is easier to solve this problem from the elevator frame. So we will try to find out the time of bolt's free fall in the elevator frame. In the elevator frame, the displacement of the bolt is in the downward direction. So the displacement is minus 2.7 meter. The acceleration of the bolt is also in the downward direction. From the elevator frame, it will be 9.8 plus 1.2, but in the negative direction. And the initial velocity was 0 because at the moment the bolt fell off from the elevator ceiling, right up to that moment, the elevator as well as the bolt were traveling at the same velocity. So their initial relative velocity was 0. So this is S is equal to U t plus half a t square, where I have thrown away the negative sign because it appears on both the left hand side as well as the right hand side. And solving this gives us t is equal to 0.7 seconds. Now they are asking you the displacement and the distance of the bolt in the reference frame fixed to the elevator shaft. So elevator shaft is essentially the ground frame. So he's asking us the displacement and the distance that is traveled by the bolt in the ground frame. In the ground frame, the bolt starts falling 2 seconds after the elevator car has started moving. In those 2 seconds, the elevator car would have gained certain speed. It can be found using v is equal to u plus at. V is 0 plus a times t, that is 2.4 meter per second in the upward direction. Until that moment when the bolt fell, it was still in contact with the elevator car, which means it was traveling at the same speed as the elevator car. So therefore, for the bolt also, initial velocity is 2.4 meter per second in the upward direction. So S is equal to u t plus half a t square. Solving this will give us minus 0.7 meter, which means in the ground frame, it appears as if the bolt has fallen by 0.7 meters in the downward direction. But how do we find out the distance traveled? Distance traveled can be found using equations, but the approach that I have tried using here is to draw a VT graph. If you draw a VT graph of the bolt in the ground frame, you will notice that it starts with an initial velocity of 2.4. That is this point. This is the time when it starts falling. Beyond that, it has an acceleration of minus 9.8 meter per second square. So the slope of this line should be minus 9.8. At what time will the velocity of the bolt become 0? V is equal to u plus at, t is equal to 0.25 seconds approximately. But the total time for which the bolt moves independent of the elevator car is 0.7 seconds. So the remaining time is 0.45 seconds. How much will be the velocity gained by the bolt in this amount of time? V is equal to u plus at, minus 4.4 meter per second. So this point should be minus 4.4. Now in order to find out the distance traveled by the bolt, we simply have to find these two shaded areas at their magnitudes. So distance traveled by the bolt will be half into base into height plus half into base into height. Totally 1.29 meter. I hope you have learned something in this problem. If you want to learn more about why was it easier to solve this problem from the elevator car frame and not from the ground frame for at least the time part, then please have a look at few more theory videos of mine. And I hope you have learned something in this problem. If you want to learn more about why elevator car was the right frame to find out the total time of travel and not the ground frame, then please follow a few theory videos of mine that also have uploaded on YouTube. See you.